Now let's see the criteria in terms of Gibbs free energy change. We'll start with Clausius inequality. TdS is greater than or equal to du plus PdV. Okay. In this equation, we have to incorporate Gibbs free energy change. What is Gibbs free energy change? G is equal to H minus Ts. But what is H? U plus PV, or G is equal to U plus PV minus Ts. From this, what is dG? dG is du plus PdV plus VdP minus TdS minus SDT. Okay. From this, we can derive an expression for du plus PdV. What is du plus PdV now? Bringing the other terms to the other side, dG minus VdP plus TdS plus SDT. Okay, now we have an expression for du plus PdV which we can use in Clausius inequality. TdS is greater than or equal to, for du plus PdV we'll put dG minus VdP plus TdS plus SDT. Since TdS is on both sides, we can cancel it out. What's left is 0 is greater than or equal to dG minus VdP plus SDT. Okay, now we'll see the criteria for spontaneity and equilibrium. So what we have to do? We have to keep dP is equal to 0 and dt is equal to 0. Then the criteria becomes dG at constant pressure and temperature is, here dG is on the lesser side of this arrow, less than or equal to 0. The other terms becomes 0. dG at constant pressure and temperature is less than or equal to 0. For spontaneous process, dG at constant pressure and temperature is less than 0, and for in a reversible process at equilibrium, dG at constant pressure and temperature is equal to 0. This is criteria for spontaneity in terms of Gibbs free energy change. The criteria for spontaneity is also known as criteria for feasibility or the criteria for reversibility. Okay, now we have derived the criteria in terms of internal energy. Du at constant entropy and volume is less than or equal to 0. In terms of enthalpy, we can write dH at constant entropy and pressure is less than or equal to 0. And in terms of Helmholtz free energy, dA at constant volume and temperature is less than or equal to 0. dG at constant pressure and temperature is less than or equal to 0. These are the conditions in terms of various thermodynamic functions: internal energy, enthalpy, Helmholtz free energy, and Gibbs free energy change. You might notice that all these functions should be less than 0, should decrease during a spontaneous process. Okay, the only variable, the only thermodynamic function that should increase during a spontaneous process is entropy. Entropy is the only thermodynamic function that increases during a spontaneous process. All other thermodynamic functions decrease during a spontaneous process. Okay, this is the criteria for spontaneity and equilibrium in terms of various thermodynamic functions. Okay, by these equations we can predict the feasibility of a process, and we can predict whether the process is reversible or irreversible. Okay, so now we are coming to the end of this class, and we have discussed Gibbs free energy change, Helmholtz free energy change, and criteria for spontaneity and equilibrium, along with the variation of free energy change with temperature. Okay, that's all for today. Thank you.